I created an assumed benchmark. Any point that you start, if you're going to compare that point to the final point, because it's going to end at the same location, you can give it any value. I gave it a value of 0. I could have given it a value of 1,000. The idea would have been, like in my case for this one, it shows you that my assumed elevation at the first station was 0. My my theoretical elevation at the same station at the end of the survey, in this case, was 0.023 inches, which shows you that there was some kind of error involved. So the closer we can get, the more accurate we get. So if that had said 0, it would have been a perfect survey, or considered a perfect survey.
So that's considered good?
That would be considered very good, yes. Yeah, because that's 1 in 72,000 feet, so yeah. Any other questions?
Thank you for the
application of creep. So how many people have ever heard of creep before? Just by show of hands. Yeah, not a lot of people, but actually it's in our daily lives. We can see it through applications of the jet engine turbines, in glass windows, in incandescent light bulbs, nuclear power plants, or in other type of heat exchangers or other systems where temperatures are high. So in jet engine turbine blades, creep can be caused when the blade comes in contact with the casing, and the result of this creep is the failure of the blade. So when you see the blade in like a turbine engine blade, actually it's a force pulling on the blade because it's rotating. It's going at a very fast pace. So there's a force on it, and then the engine is a high temperature. So the high temperature mixed with the force, the strain of the blade, causes the blade to creep. And then the casing that the blade is in, it can come in contact with them and cause the blade to fail.
Sammy Patterson. Nice to meet you. I'm Jonathan.
Good. Well, tell me about your metabolic flux analysis application to pre-transplantation of ENS1 beta cells.
Okay, well, this summer I had the pleasure of working at Rutgers for their REU cellular bioengineering program, and I worked to find a way to improve the islet transplantation, which is a method for treating type 1 diabetes. Currently, there are 1 to 2 million people in the United States that have type 1 diabetes, and currently there are 3 different ways to treat type 1 diabetes. The first is exogenous insulin injection, in which a person would inject insulin into themselves to monitor their glucose level as well as control it. The second involves pancreas transplantation, where the pancreas is taken from one person and transplanted into another. This is a problem because it involves a major surgery, and then it involves major immunosuppressions that the person will have to take for the rest of their life. And there's only 2,000 people in the United States that have pancreases that are eligible for donation, while there are 1 to 2 million people in the United States that have diabetes and 15,000 new cases each year. So our method of research involves taking a portion of the pancreas, which is also called the islet of Langerhans, and it is a group of beta cells which are responsible for producing insulin within the cell. And as you take this islet and transplant it, the islets are then not able to survive under the hypoxic conditions. And hypoxic means low oxygen, which is usually around 1%. And you would sometimes maybe imply that you would take these islets and put them into the liver sinusoid, which is another organ which these islets can survive. So we want to find a way to create an environment where these cells can survive under the low oxygen conditions, because we understand under low oxygen conditions, the cell enters a lower energy state and thus has a lower amount of insulin secretion.
So why is it that in a hypoxic level, why is there lower energy in a hypoxic state?
There's lower energy in a hypoxic state because the cell isn't able to undergo glycolysis and normal metabolic activity as it would in 20% oxygen, while in 1% oxygen the cell has to resort to other methods of getting energy. And like one of the side effects to type 1 diabetes is ketoacidosis, where the individual can't break down the sugar, so the body will resort to breaking down fatty acids, and this will create ketones, which are very harmful to an individual.